vuelta, queridos fellows y queridos amigos en el canal de YouTube y nuestros queridos becarios. Ahora seguimos. Vieron que hemos empezado los primeros días con temas más de infraestructura, hemos pasado
we started the first days with a little bit more about infrastructure, and now we are focusing more on cybersecurity and cybercrime. We started with a well-known expert as Chris Painter, and then we continued with digital identity with Michael Pallet, and now we have a panel with a lot of friends from Latin America and the US. The topic is going to be cybersecurity in critical internet infrastructure and industrial environments. I'm going to be the co-moderator of this panel with my friends Yesenia Granillo from El Salvador. Hello, Yesenia. How are you?
Hola, cuánto gusto.
Hello, it's nice to see you. Olga, Adrian, thanks for the invitation. Greetings from El Salvador. It's nice to see you, Yesenia. I always tell a story that I have with Yesenia that is very funny. I'm very punctual, and sometimes I suffer because of that, because it's not the standard in Latin America. And when we organized the second edition of the school in the Organization of American States headquarters, I asked everybody to be early because Vincent was coming to greet us first time in the morning, and I asked everybody to be there on time. I was there on time, and Yesenia was there, and she had arrived really early, and she was talking with him about internet and interesting topics, and I said, well, the good thing about getting there early is to have an exclusive conversation with the father of internet in the OAS headquarters, and I always remember that. I also remember how you arrived earlier and you were able to talk to Vince, and I think that you also remember that. Yes, it was a very nice experience. I don't think that it's going to happen again. It was great. You never know, you never know. Thanks, Yesenia. I'm going to co-moderate the panel with Yesenia, and we have three experts. Gerardo González is a friend from Argentina. He's a teacher professor at the Tecnológica National University in Argentina. He worked a lot of years in the oil company of Argentina, YPF. He's an expert in industrial infrastructure, security in industrial infrastructure. Suzanne Wolff is an expert.
Susan and Eduardo, I will switch to
Don't worry, Susan and Eduardo, I'm going to switch to English.
If you want to follow the translation, you have to go to the YouTube channel.
If you want to follow the translation, you have to go to the YouTube channel.
I will make some explanations in Spanish. Susan es una experta en seguridad.
Susan is an expert in DNS security. She was a member for many years of the ICANN board of directors in topics of security in domain names. And Eduardo Izicky is a researcher on cybersecurity. He's from Brazil, but we're not going to speak in Portuguese. We're going to speak in Spanish and English. He's based in London doing some research work nowadays. So you are in a very beautiful city, Eduardo. And as I told you, Yesenia is the president of ASADETICS from El Salvador. She's a lawyer and she's an expert on internet and cybersecurity topics. I'm going to give the floor to Yesenia, so she opens the floor for our speakers, for Gerardo, who is here in the city of Buenos Aires first. Thank you, Olga. I want to thank you and also to the Association of New Technologies for being part of this school of internet, this edition of the school. Cybersecurity is a very important topic, especially when we are talking about critical infrastructure. In the last few years, it has been the object of attacks. And so we are addressing this topic, and especially for people like me, this is very technical, but it's a very interesting topic that allows us to learn a little bit of everything. And in that sense, we are going to open this panel with the first question for Gerardo. Welcome, Gerardo González from the National Technological University of Argentina. He's an industrial cybersecurity consultant. And I would like to ask you, Gerardo, which are the main differences from the point of view of cybersecurity
tecnología de información y OT, tecnología de operación de ambiente industrial.
Operational technology in the industrial environment.
Okay, gracias. ¿Qué tal, Yesenia? Olga, ¿cómo están?
Thank
Primero que
you.
nada, agradecer
Hello, Yesenia,
la
Olga.
participación aquí.
First, I want to
Y es un honor para mí poder
thank you
estar
for
en la
inviting me
escuela.
to participate.
Estuve
It's a
en el
great
momento
honor
que
to be
acabas de
part of this
comentar,
school.
Olga, cuando Yesenia se encontró con
I was
Vincent, Serge, y yo
there when
también
you
estuve ahí
in
en
the
ese momento
OAS.
porque también tengo la
When
costumbre
you
de
talked
ser
about
puntual
Olga,
y
you talked
llegar
about
temprano,
Vince
así que
being
también
there. I
fue
was also
un
very
momento
punctual, and
único,
it
como
was
decía
a
Yesenia.
unique
Y
moment, as
respondiéndote la
Yesenia
pregunta,
was
Yesenia,
saying.
tengo
And
una
to answer your question,
presentación para
Yesenia,
apoyar
I
la
have
contestación de
a
lo que me acabas
PowerPoint
de
to
preguntar,
support
con lo cual les voy a
what I'm
estar
going to talk about.
compartiendo la pantalla.
So I'm going to be
¿Sí?
sharing the
Si me
screen.
permiten.
Muy bien.
Y lo que les voy a estar pidiendo es que me confirmen que
I'm going to ask you
estoy
to tell me if you can see it.
compartiendo allí.
Yes, it's
¿sí?
okay.
Sí.
Yes, you are sharing the screen.
Bien. Entonces, para responderte la
Okay, so to answer your
pregunta, me decías
question,
acerca
Yesenia,
de los mundos IT
you were
y
asking
OT,
about the different
¿sí?
environments, the IT and
Pero
OT.
no se está viendo.
Can you see it?
Sí, ahí se ve bien. Ahí se ve. Ahí se ve bien, perfecto.
A ver.
Ahí está, ahí está, ahí está. Se
Ahí
fue.
está. Ahí está, ok.
Ahí está.
Ahí sí. Arrancamos.
Sí,
primero voy a hacer un poquito de historia muy rápidamente, recordando
First, I want to tell you a little bit about the history
lo que
of
fueron las revoluciones industriales.
the different industrial revolutions. The first industrial revolution
la
at
segunda
the end of the
a fin de
1700s, the
1800.
second one at the end
La
of the
tercera
1800s, and the
tomamos como
third,
hito el 1969, la
it
creación
was the
del primer controlador
1969
lógico programable,
with the creation
PLC,
of the first
ahí en
programmable
1969,
controller in
para estar en el día de
1969.
hoy en la cuarta
And
revolución
nowadays, the
industrial.
fourth
Lo que
industrial
quiero aquí
revolution,
destacar entre
and
estos
here I would
puntos
like to highlight
es los tiempos entre las distintas revoluciones
the
industriales,
timeline between the
entre la
different
primera y la segunda, la
industrial
segunda y la
revolutions, between the
tercera,
first and the
han
second, the second and the
transcurrido
third.
100 años, mientras
100
que ya para llegar
years
entre la
have passed,
tercera y la
and
cuarta, con
between
la
the third
creación
and the
del primer
fourth,
PLC que les
with the creation
mencionaba,
of the
que
first
ahora
PLC that I
vamos a
was
ver por qué
mentioning,
llamamos que este dispositivo pertenece a la tecnología de las
and now we're going to
operaciones.
see why
Y
we
lo que
talked about
podemos
this
hablar en la
device.
década del
And what we can
2010,
say
donde se
about the
ubica, y la historia dirá
2010,
después cuál es el hito
and then
exacto
history
en
is going to tell
esto.
us which is
Yo
the
tomé
exact
el inicio de
point
la
that
industria
issued this fourth
4.0
revolution,
por
but
el concepto del
I took
Internet
the start of
industrial de
this
las
with the
cosas que
concept of
apareció en la feria de
Internet
Hannover
of Things
allá en 2013.
that was
Entonces
mentioned
vemos
in
que
the
tan
Hanover
solo
Fair in
transcurrieron
2013,
40 años,
and
lo
only
que nos
40
da
years
la
passed.
idea de un crecimiento
So this gives you an
exponencial a
idea of
nivel de
the exponential
tecnología.
growth as regards
Entonces,
technology.
lo que vemos aquí,
So
esto
what
es
we can see
que
here is that
la tercera revolución industrial es lo que empieza lo que llamamos
third industrial
la
revolution is what
automatización,
starts
esa
with
tecnología
automation,
de la operación hacia lo que
operations
hoy llamamos el
technology,
Internet de las
and
cosas, el
going to
Internet
what we
médico
today
o el
called
Internet
Internet of
industrial de las
Things
cosas.
or
A partir
industrial
de los
Internet of
70,
Things.
esto
As
comienza
of the
en una
70s,
evolución de
this started
convergencia entre esos
to
mundos de
evolve and to
IT y de
converge
OT, entre
in
esos
the
mundos
IT
de la
and OT
tecnología de la
worlds
información
or
y la
environment,
tecnología de la
the information
automatización o la
technology and
tecnología de las
automation
operaciones,
technology,
haciendo
environment,
converger a
operation
estos mundos,
technology, and
especialmente dentro de las
converging these
compañías.
environments within the same
Entonces, es aquí
companies.
donde
And this is
repasemos bien
where
definiciones para estar todos de
we can
acuerdo en
talk
lo que
about
me
the
acabas
different
de consultar.
definitions so that
¿Qué
we
entendemos por
have a
IT?
common
Por IT entendemos
base.
todas esas tecnologías
IT
que
is
están
all the
asociadas
different
a la
technologies
información, a
associated with
almacenarla, a
information,
recuperarla,
storage in information,
transportarla,
recovering it,
manipular los datos. Y lo tenemos en los
manipulating
contextos de
data,
empresas, en los contextos
and
de
we can find it
negocios,
in the context and
obviamente
environment
ya
of
hoy
business,
muy instalado en el hogar, más aún
nowadays
con el último año y medio, casi
in
2,
homes,
que
with the
llevamos
last
con el tema de la pandemia y
year
todos
and a half
tenemos
with
a
the
esta
pandemic.
tecnología de la
We
información
can see that
dentro de
we all
nuestros
have this IT
hogares,
technology in
está
our
asociado al hardware,
homes,
al
and
software,
it
a
is connected
internet,
to hardware,
a todo
software,
lo que es
internet,
el e-commerce,
and everything that has to
servidores,
do with
conectividad.
e-commerce, servers,
La
connectivity.
tecnología de la operación está
OT
directamente relacionada a los
is
procesos
related
industriales,
to
a los
industrial
sistemas de
processes,
control,
to control systems, to oversight of these processes. And this is where we can see names that are not so popular, such as HMI, SCADA, PLC that I mentioned before as the devices that marked the third industrial revolution, which are devices that are connected with an industrial process, helping controlling it, operating it, and monitoring it. So taking into account these two big differences between IT and OT, and what we understand about it, and the convergence that we can see today, we are going to analyze from the cybersecurity point of view what this means. In cybersecurity, what we have as regards IT priorities, which is the mature market of cybersecurity with more than 25 years of history since companies started to connect to internet in the 90s, the priorities go from lower to higher as regards availability, integrity, and confidentiality when we talk about information. Availability means that it's going to be available most of the time. Integrity has to do with
en su transporte, en su almacenamiento,
keep the whole information during transportation and storage and all the life cycle, and confidentiality has to do with protecting this, and that it cannot be accessed by somebody that shouldn't have access to it. When we talk about OT, we have the first paradigm shift here, because priorities are upside down here. In the OT world, OT environment, the priority is availability.
No tanto así la integridad y confidencialidad del dato, que no digo que no sea importante,
not so much,
pero se invierten
confidentiality or integrity.
Esto es porque el mundo de OT,
and this has to do with the fact that the OT environment, the industrial systems environment, automation, comes from something that we call safety. In English, we have two words to talk about this: safety and cybersecurity. While in Spanish, we always talk about only one word, that is security. As for safety, what we understand is to protect people from the damage that things or devices can cause. And when we talk about cybersecurity, what we do is to protect information and devices from the damage that people can cause on them. So, since this comes from the fact of protecting people and the environment, especially, the availability of industrial systems is over the need of integrity and confidentiality of information. We also have some different approaches that you can see here. In the OT environment, we have a longer life cycle for devices and software and hardware. We work more in real time and not so much in the IT environment. And we also have a difference in availability, as I mentioned, and another risk management. Risk in the OT environment, in industrial cybersecurity environment, is connected to damage, death of people or communities, and protecting the environment. So this convergence, what is going to bring about is, from the technology point of view, is implementing upgrades, updates within a software or OS. And it has a difference with what we are used to in the IT environment. And there are also other vulnerabilities that are not so mature in the IT world, such as passwords are preserved by default. Not in all devices we can see cryptography and plain text. So what I was telling you is that the main difference is what we see here. The IT world is a transactional world that is going to work in the virtual environment. And in the OT environment, it's going to be focused on industrial processes. It's going to work in real time. It's continues and it's going to have an impact on the physical world. As we were saying, the risks are that an impact in the processes can have a direct impact on people and damage them, even causing death. It can damage the environment and, of course, damage the image, brand, and production. The big difference is, as I was saying, that this convergence starts to push in real time information as regards production and the different industrial systems that are going to need or are going to be needed by top management in the company. More and more corporate networks are getting together with control networks, and this is where we can see all this idea of the OT and IT convergence, and there is a concept that is the name of this panel that has to do with critical infrastructure that probably we are going to talk about in this panel, and we are talking about protecting critical infrastructure, industrial cybersecurity, and we also have the industrial critical infrastructure, where the most important thing is to take into account the shifting paradigm, the difference from the point of view of cybersecurity, focusing on these three things and adding the safety concept that I mentioned. I don't know if I answered your question or if there's any other question, Yesenia.
Perfecto. Me parece que ha sido completamente claro. Gracias,
Right, I think that you've been very clear. Thank you, Gerardo.
And
later we're going to
Bien, perfecto. Voy entonces ahora a dejar de compartir.
Okay.
Gracias, Gerardo. Me queda una impresión de que es un mundo totalmente diferente
Gerardo,
a
otros
mundos de infraestructuras críticas en el industrial, ¿no? Es una especialidad muy específica, y celebro que la Universidad Tecnológica Nacional te tenga como docente y tenga una especialidad en eso. Las universidades tienen un rol fundamental en formar profesionales en todas estas disciplinas, ¿no? Gracias, Gerardo. Y ahora I will switch to English now. Suzanne pero no te vayas, Gerardo, quédate ahí con nosotros.
But please stay tuned.
I will make some questions to Eduardo and Suzanne now. Eduardo, how are you? Good to have you virtually. Maybe we can meet sometime in the near future in person. And as a researcher, I have a question for you. What do you mean by critical infrastructure? Do countries and international organizations agree on which infrastructures are really critical? Can you help us in understanding this difference or this difference in between the concept or the understanding of what is a critical infrastructure for different actors in this ecosystem? And welcome to the school again.
Thank you, Olga. It's a pleasure to be here again. Despite we're being apart, we're being on screen. It's always a pleasure to share the panel with you and my colleagues. Well, that's the true question, right? The idea of what is exactly critical. When you ask, do countries or institutions or international institutions, they agree on what exactly is critical infrastructure, the blunt answer would be no. We don't have a formal treaty saying that energy, for instance, or power plants or hydro dams are necessarily considered critical infrastructures. We don't have that unfortunately, we don't have that on paper. However, when someone takes a closer look to national documents, and I'm referring here to, for instance, national cyber strategies, they often agree. Countries often agree on what are the sectors considered to be critical. For instance, most countries agree that telecommunications and energy supply and transportation, finance, water, sewage, they are considered to be critical infrastructures. It's reasonable, of course, to conclude that, in every country seems to be concluding that in their own documents, because when someone imagines a cyber attack against those kinds of infrastructures, it's easy to see the great damage and loss of human lives and so forth, as Gerardo pointed out in his presentation. So I would say that for the moment, we don't have a clear agreement on the subject. However, countries on their own side, they do agree. A second point that I would like to stress is the idea that this is not only a governmental issue. It's not only the public sector job or responsibility. Although societies tend to turn to governments to their safety, one must be aware that the critical infrastructure landscape is composed mostly by private entities. That's the case in Brazil, and I most likely think that's the case in Latin America. Most of our transportation models, for instance, airports and ports, and even railroads, are mostly private owned or private administrated infrastructure. So this is an issue that requires some level of agreement in the national level also. So governments should look for the private sector to decide upon the best course of actions when we think about protecting those infrastructures. And I would say that although rare, if you think about in the recent history of cyber attacks, we don't have that many cases of attacks against critical infrastructure. The mere prospect of one, it's hideous. So we should indeed look for some sort of consensus of the international level so we can optimize our security in this sense. I don't know that answers most of your question, but please feel free to fire away.
I have a clarifying question for you. I see a lot of discussions and comments about the cyber attacks, mainly focused on private companies or individuals at home, working from home, which has changed totally the way that we use our computers at home, and we are perhaps not so well protected as when we were working in a company or a big organization or a state-owned infrastructure. So how do you see this happening in companies like power companies, oil companies, or water or other industrial institutions or infrastructures? You see they had the same challenges, or you see it has been more controlled or different?
Well, I would say that's a bigger challenge for those companies when you think about it, because I'm borrowing some of the Gerardo presentation. He correctly pointed out that the industrial architecture is a bit different from the ones that we are using every day on the internet. And in the moment that we needed to turn to home office to supervise the operation of a power plant, for instance, we open more doors to attackers. We have a bigger surface of attack, so it's definitely a concern. I would say that it's a precious target, so to say, for hackers. We saw some terrible incidents about ransomware on the East Coast of the United States. So I'm not necessarily sure that happened because of home office, but certainly home office makes a complex environment even tougher to defend against. So I would say, yes, this is something that brought up new issues for cybersecurity in industrial complexes.
Eduardo. Now I'll give the floor to Suzanne. Thank you, Suzanne, for being with us. I know you're very busy And thanks for PIR for supporting the school every year for a long time. I want to tell you that Suzanne is an expert in security at the DNS, and as Eduardo and Gerardo said, there is no exact convention or definition of what is critical infrastructure, but I'm sure that the domain name system and the coordinated infrastructure for the domain name system is a very important critical infrastructure. Maybe Suzanne can comment on that. And I have a question for you, as there is no convention about what's a critical infrastructure, even for something like the root of the DNS, which is pretty easy to agree is essential to much of the function of the internet, and there is no shared understanding of the line between private and public infrastructure either. Can perhaps content on content platforms could be considered critical infrastructure? And I would like to add another question. How do you see the challenges for the domain name system in relation with security, domain name system abuse? I know you're expert in that field, so the floor is yours. And thank you very much for being with us this morning in Argentina. I think you're based in the East Coast, so it's a morning for you, almost lunchtime.
Almost lunchtime, yes. Thank you very much, Olga, for the invitation. Very happy to be here. I do have some comments to offer that I think touch on the questions you're asking, and then I think I've left some time for additional questions and discussion. But I'd sort of like to start by setting the stage around DNS as sort of an example of internet critical infrastructure and how it fits with some of the established thinking and how it's different. As colleagues have described, there are norms around critical infrastructure and what is or isn't, even though there's no firm shared understanding. And the internet is kind of behind the curve on that. And DNS, because I've spent a lot of time thinking about these questions, sort of illustrates some of the principles. I also need to say, I work for PIR, as you know, and we're very, very happy to be supporting this meeting. However, I'm speaking for my views, and these are my observations from, frankly, more years than I like to think about. And this meeting has included a lot of thoughtful presentations on cybersecurity and the internet, and it's in a vast, vast subject. So I'll try to fill a particular space. Partly that I come from an engineering perspective initially, and then from policy. And also that it's one piece of an enormous system, a very complicated system. So DNS and the public internet are components of a complex system as big as the digital planet. Internet and DNS is critical infrastructure, as Gerardo notes. Formally, internet generally is not. I looked at your paper, and that was really very helpful, because having it in a table there sort of confirmed the observations over the years that for the most part, the internet is behind the curve as a critical infrastructure in terms of the legal and policy framework. So what we have is formally, mostly it's not critical infrastructure, but in the common sense, in the informal sense of this is something that people rely on and will notice if it's missing, it's definitely, in that informal sense, critical infrastructure. And it really would be wise of us to consider it in that light and then reason from there to what policy regime ought to be around it. So just for a couple of definitions, DNS is critical infrastructure. We need to think about that from the common use of those words. For cybersecurity, also very big topic, and trying to provide a basis for how we think about it, and from my background, you can be dealing with malicious action or with accidents and errors. They matter just as much as malicious activity. And sometimes you can't tell which it is. And often in terms of addressing an incident or a concern, it doesn't matter. There's also a very fundamental infrastructure trade-off about the internet that I think holds for complex systems generally, that there's a trade-off between protecting a few resources and having widely distributed resources that then have to be managed. And in hardening resources against misadventure or attack, there's some basic architectural decisions and policy level decisions that have to be made. And frankly, it's all trade-offs. There are disadvantages, there are risks, no matter how you approach these questions. So if you sort of dial in with a little more detail, why is DNS critical? For folks who might not know, who might not be familiar, I'm not going into a lot of technical detail because we have limited time, and I don't think it's necessary to understand at the top level. DNS connects users, systems, and resources. The most common use is to map names of things like websites and email addresses and applications to network addresses. Those network addresses used are how basic reachability of a network resource is done. Load balancing, management of resources. So lots of other critical resources use DNS. It's one of the few really basic services that bind the internet together. However, it's also just another software and network system that exchange messages between machines. It relies on other resources as well, such as network connectivity, server and software availability, and routing, which we will get back to later. DNS is designed to be resilient in particular ways. It was created for a less reliable network than we have today, so there's a lot of replication and caching data. It's built to be decentralized and to have redundancy among resources. So if one system is down, you should be able to reach another that can serve the purpose. The operator of example.org mostly controls whether users can find www.example.org, and the user's access provider is involved. The rest of the internet doesn't have to be working for that transaction to work. There is a central resource involved in the DNS, though, the root zone and the root servers. All they really tell you, they have a very small but very important piece of information. All they really tell you is where to ask for the next level of detail. The root tells you what servers to ask for .org, which can direct you to example.org. So DNS is this mixture of the distributed and the centralized. Threats to the DNS are the same as the threats that have been discussed, I believe, in many sessions in the meeting here. Malicious activity, denial of service, hijacking, that DNS is subverted to give the wrong answer to a query, server compromise, but also accidents and errors. The modern DNS is a very complex and dynamic system, far beyond its original design parameters. Configuration management is challenging because there are many options. The technical protocol is complex because it has to work in many different sets of conditions. And there are many interoperability requirements so that your ISP's service can connect to a service on the other side of the world. It's also an issue for DNS, sort of going back to the critical infrastructure. We're just a baby. DNS and the internet are still new, and other critical infrastructures have had more mistakes to learn from. Never underestimate the value of making more mistakes in the area of being able to protect against threats and misadventure. So for DNS, it's sort of an overview of how we protect it. Lots of attention to security. The protocol now is not perfect, but it is much, much better than it was 20 years ago. In terms of data integrity, in terms of privacy and limiting data leakage, and all of the wisdom we've learned by building the internet and other very large distributed systems, all of that also applies to keeping the DNS running. So there's experience with making servers and software more resilient. There's some experience with turning enterprise level DNS into part of incident response and business continuity for any enterprise, particularly one that relies on connectivity to do business, which is so many today. And there's been a lot of understanding of how to interoperate effectively against malicious activity, which is both information sharing within the industry, within network operations, but also, and this is where we get to more conventional formal policy notions of critical infrastructure. There's been much building of relationships with governments and law enforcement and other policy authorities and legal authorities simply out of need. No one has come along and said, nobody came along 20 years ago and said, you guys will someday be critical to the functioning of the global internet, so let's get ahead of that. So a lot of what happens in both engineering and policy is reactive, but it is happening, it does evolve. Just as kind of a case study, I have two, and the first is about the DNS root specifically because it illustrates some of the principles about both the engineering and the policy regimes and how they're evolving. DNS as a protocol, as a service, is widely distributed. Servers that answer queries are critical only to specific domains. Resolvers that make queries are critical only to specific users or enterprises. But there is the one central component to the DNS, the root. There's very little information in the root zone file, and people have worked hard to keep it that way because you want the single critical piece, the centralized piece, to be as small as possible. There are a set of servers designated as sort of the last resort to reach the root zone. Those are at well-known IP addresses because a DNS resolver needs somewhere to start. You need somebody to ask a question when you don't know anything about finding a name. Resolvers remember what they've been told. So we also managed to minimize the number of direct queries to root servers, but they would eventually be missed. They do matter, just not, there would not be an immediate crisis to have the root server system under attack, but it is quite important long before it becomes urgent, and it eventually does become urgent. And the system is subject to all the threats of any public-facing internet service. You don't know who's trying to connect to your service. You have limited control over it, and you have very limited control over whether they will exploit a weakness you didn't know about. So how do we protect it? Engineering expertise and resources. And that tends to focus in the direction of diversity and wide distribution and reducing the importance of any specific resource. There's a technique called Anycast that allows for wide replication of DNS servers. And for the root, there are 12 organizations that are responsible, but hundreds of servers all over the world. And they're compartmentalized so that a failure of one or even a large number of them does not have an impact on the availability of others. All the root servers are operated by professional network engineers with significant commitment of resources to monitoring capacity and the threat environment. So this is a very seriously held responsibility. And the root server operators are not under a single organizational or technical control regime, which broadens the attack surface. Technical work is in progress to make it easy and reliable, to further distribute availability of this key piece of information, to make it easy and reliable for local networks, enterprise or carrier level networks, to copy the entire root zone easily and keep it up to date, which further reduces dependence on the root servers. And that's the direction that engineers tend to think. If you have a single point of failure, if you have a concentrated resource, one really good way to protect it is to make that single resource into many and to make each one less important. At the policy level, there's also been significant activity around this system in the direction, instead of, I believe for the most part, policymakers assume that technologists are taking good care of the part that's about diversity and distributed resources. However, there's been increasing interest from policymakers around transparency of the system and how it works and how well it's working. Concern about having shared BCPs. And there's some pieces of governance of the system that have not been formalized. That some root servers are designated critical infrastructure in their home countries. For instance, my colleagues in Sweden, I believe, have a very close relationship with their government. There's increasing interest in technical details and operational data, which the root server operators are trying very hard to accommodate. And there's current policymaking activity within the ICANN community to formalize the remaining pieces of root server governance, such as being able to agree on service level expectations so that if someone is failing to hold up their piece of the system, it can be readily diagnosed and there's action that can be taken. And that's all very much an evolving picture, again, because the internet is not even old enough to drink in that sense. As sort of another case study that illustrates, I think, some very different principles, there was the Facebook outage earlier this week, which, of course, everybody heard all kinds of things about. First, I want to say that this is not about criticizing Facebook or their engineering. The engineers I know there are terrific, and they probably had the worst day of their careers on Monday. They have billions of users, hundreds of thousands of servers and routers, tens of thousands of employees, and they work very, very hard at security and resilience. And the lesson is not that they had a problem, but that anyone can have an unforeseen problem that they don't know how to address. They had an outage of all of their services for most of a day, and the impact was immediate and severe. This was literally global news. And besides that this can happen to anyone, and there's no room to say, there's no room to criticize either their expertise or their level of care. It can happen to anyone, and the other piece of it is that I think they illustrated the point earlier about the trade-offs of different types of security. Because some of the things that they had done to protect against certain threats made it harder to recover from the problem they actually had. So, for instance, centralizing and hardening some of their security functions in their internal network meant that they had no way of rebooting the physical access systems. So the people that could fix the servers couldn't get access into the data centers to fix the servers. And this is just, again, an example of you have to pick your risk, you have to pick your mitigation, and sometimes you have to evolve. The other thing is that DNS was not the primary failure. This was widely reported as a DNS failure, but it was, as far as anyone can tell, and I have to say I don't have specific knowledge, I don't have privileged knowledge, but from the postmortem that they published, and props to them for that, this was a cascade of failures. A human error in the routing in a routing update, followed by a software bug in the system that was supposed to catch such human failures, followed by a routing failure that meant that the servers couldn't reach each other. The routing failed first, so the DNS servers couldn't find the data they needed, so the immediately visible symptom was a DNS failure. But these unanticipated dependencies made recovery very difficult. And again, this is typical. This is sort of inherent in the nature of how these things work. So the question is, what can Facebook do? From the engineering perspective, they have long since accepted, as many of us have, that a complex and large-scale system is impossible to fully understand. There's always something you overlook. There's no perfect shield. BCPs can help engineers look for faults and failure modes. They've already said they do lots of testing of system failure scenarios, and now they have some new ones. So they continue to improve their testing and continue to study the experience of others as technology and practice evolve. The policy options they might have are a little more novel, because it gets back to the question, and Olga has probably been waiting for me to get back to this, is Facebook critical infrastructure? Should it be treated as such legally and in policy terms? Most of the attention on Facebook has been about content, at least in the North America and Europe. But the interesting thing to note this week is that loss of access to non-controversial content has an economic and social impact. Facebook provides infrastructure services like user authentication. If you've ever seen a website that says sign in with Facebook, that's servers talking to each other. That's a commercial service that was impacted by this outage. Speaking from experience only as, with US and similar policy regimes, there's a tendency to dislike regulation of private entities, which Facebook is. They're a privately held company. And there's a tendency to want to trust market forces on private companies until the last possible moment that's proven inadequate. Noting also that Facebook has sometimes said that they support cautious regulation. So there may be benefit in proceeding in that direction. But I do think that we're going to see more and more pressure on Facebook and some of the other big platforms that if they want to be treated, if they want the advantages of being large and important and critical to the day-to-day functioning of many people and businesses, they're going to have to accept the other side of that, which is very likely to include regulation. And I hope that's illustrated at least some useful principles out of, the DNS is kind of a case study on an internet infrastructure. And Olga, I think that touched on a couple of your questions.
Thank you. Thank you very much, Susan. It's very interesting what you have been explaining to us. Some comments come to my mind, and in relation to what the comment that you made from the attack, the incident of Facebook on Monday, and the distributed infrastructure of the DNS, maybe considering that the DNS has such a distributed infrastructure all over the world makes it less vulnerable to this kind of security failures or attacks? Do you think this distributed infrastructure makes it more resilient? And also, very interesting what you explained about the root servers. They are managed by different organizations and very skilled professionals. So that, at least to me, gives me the impression that this distributed coordination makes it less vulnerable than putting it all together in only one point of organization or management.
Very much so, and it's good to point out that this is sort of fundamental to how the internet came to be. That it's not a single network; it's a network of networks, different organizations, different businesses, different carriers, and they don't. There's lots of diversity of ownership, lots of diversity of technical requirements on the networks that make up the internet. What makes it the internet is that they talk to each other, that they interoperate, not that they're all run by the same people or do the same things. So certainly as an engineer, my first instinct when I see an exposed vulnerability, a single point of failure, something that can be used to compromise my infrastructure, I want to spread that out. I want to make the attack surface bigger. I want to make any single resource less important. I want to make sure that any attack or misfortune has as small an impact as possible. And that's very much the engineering philosophy that underlies the internet. From a policy perspective, I think there's a lot of back and forth. There's a lot of tension between it's easier to regulate if it's in one place or if it's carefully defined and carefully scoped. And I think the tension between those things is where we get a lot of creative solutions to some of the problems we have. I think you're absolutely right. My unqualified answer about distribution of both the technology and the control over the root server system, I think that has been a tremendous strength from the beginning. It was basically designed that way, that it didn't belong to any single geography or any single entity. And when Anycast became available as an engineering solution to further distribute those resources, people jumped on it. They were very happy to be able to do that. And there was not a corresponding policy imperative. It was just about making the service better. And again, when it's in terms of making the service more available, more resilient, in many ways, I think the policy answer should look to the engineering answer. That the thing to do is distribute things more widely and reduce the impact of any single failure.
Thank you very much.
When you can't reduce that any further, when there are critical resources, when there are critical facilities, is I believe the American legal term, you have to be realistic that there is a policy option around direct regulation. So I know that's not a definitive answer, but it's sort of a suggestion of where we look.
It helps a lot, my question. I will switch to Spanish now because we have some questions for Gerardo. Gerardo, tenemos como 10 minutos. A ver.
Gerardo, we have like 10
leo dos
minutes
o tres
here.
preguntas. ¿Qué tan críticos son los sistemas escada? ¿Cuál es la relación y cobertura entre CIP y seguridad cibernética? Y después hay otras preguntas. Bueno, esas y después leo otras más que son un poco más filosóficas.
And I'm going to read out some other questions that are more philosophical in nature.
La primera parte era respecto de la vulnerabilidad de los
The
estados.
first part was in connection with the vulnerability of the SCADA systems.
Como les decía, al ser uno de los principales puntos dentro de
as these are the main points within the control systems, the industrial control system, SCADA is the surveillance and the data acquisition system. It's the one that controls the industrial process. An attack perpetrated in any of its form with all vectors and threats is going to attack and put at rest that industrial process.
Esos son los
having
problemas sobre los cuales se diferencia la parte de OT de la parte de Haití. En Haití, cuando atacan un servidor o cualquier tipo, por más importante que sea, el daño puede ser muy grande económicamente,
regardless
pero no
of the
se puede
importance,
causar un
you could
daño
have or
al mundo
cause
real
economic damage,
físico.
but you cannot cause
Eso
any
es lo que
damage to the
sucede
physical
con el
real
caso de la
world.
vulnerabilidad de los
And this is
estados
what
al
happens when you
afectar
exploit
el proceso
weaknesses or vulnerabilities in the SCADA. You affect the industrial process and you put at risk
que puede ser daños a las
the
personas
actual or the real
o
world.
al
It could
medio
be
ambiente.
damaging
Por
people
supuesto,
or damaging
también
the
al proceso
environment.
industrial, a la
Obviously,
producción,
also
a la imagen de marca.
activity in the
Pero el
industrial
gran problema
process
es el impacto sobre el
and
mundo real.
the image or the
Después me
reputation of
habías
the company.
hablado de una segunda
But
parte de protección de
Sí,
infraestructuras críticas,
the
¿no?
real world.
No sé,
You
es que
said something about
ignoro
policies,
exactamente qué son. ¿Cuál es la relación y cobertura entre
What is the relation
CIP y
between coverage
CIP y seguridad
of
cibernética?
TCP,
¿Eso es
IP,
para
and
vos o
IP
para quién?
and
Ahí
cybersecurity?
me perdí.
A ver, entiendo que esa sigla habla de protección de infraestructuras críticas y
believe
protección de
that
infraestructuras
they-
críticas industriales.
Ah,
¿no?
debe
They
ser,
protect
sí,
about
sí.
physical. It's about
Por
protecting
lo tanto,
physical
no sé si
infrastructures
Eduardo quiere
and
responderla.
real
Bueno, no
infrastructure
importa, si Eduardo o...
or industrial
Did you get
infrastructure.
that, Eduardo?
Eduardo,
Which
did
is
you
the
get the
relation
question?
and coverage between CIP and CIIP security? Deben ser estándares. I don't know them. So if we don't have that information, we can search it later for fellows. What else?
O pueden ser los estándares de la NERC, de la normativa NERC de energía.
Puede ser. Okay. I think this is a question perhaps for Eduardo. Considering that if critical infrastructures do not depend totally on technology systems, considering our level of development, what other aspects of cybersecurity in developing countries should migrate or invest in relation with technology? I think what they want to ask is which things should we invest on and pay attention to in developing economies, and then if the intelligence agents should be in connectivity or working together with those who protect the critical infrastructures in the countries. Maybe Eduardo can address some of these questions.
Okay. Well, regarding developing countries, I would say that we need to invest in people. We need people qualified to do the job. Suzanne spoke correctly when she said that we need qualified people running critical systems. And I think as a Latin American, I would say that we do have a technological gap that we need to address. And of course, buying technology is necessary sometimes, and we do need it. So we import it, but we need people to manage it. So I'm sorry, you said something, Olga?
It's okay. I think we...
okay.
Yeah. Were you saying something more? Sorry, I was grabbing something of my computer. Any other comments from Yesenia and our dear experts?
Only that there are resources. There are documentation of best practices. There are folks who teach, who do technology transfer and training. And it's particularly difficult now in the all remote COVID era, but in some ways it's easier because the cost of joining a Zoom is so much lower than the cost of physical travel. There is some loss of immediacy, there is some loss of contact, but there's also great benefit there, and I can talk offline with anybody about some of the potential resources for that.
Maybe, Suzanne, you can send me by email some links that you think that could be interesting for the fellows, and I can share that with them. And thank you for mentioning that. Yes, there are many resources online. Thank you very much.
I wanted to highlight the fact or the importance of what Eduardo was saying as regards critical infrastructure and how the different countries need to mix or combine the private and the public sector and to enhance protection of critical infrastructure, not only in the industrial world, but also, as Suzanne was saying, as regards DNS, we can see that critical infrastructure are not only industrial infrastructure, but also some that are not from the industrial world. And of course, I think that this is very important, and there should be a public and private commitment in the different countries and organizations to start developing or setting committees and to developing regulations and to foster this protection in a general way. Thank you, Gerardo. It's very interesting what you are saying. I can think of different scenarios. We generally talk about cybersecurity and cybercrime.
Sorry, Eduardo, in English. Last comment?
No.
Você comprende, huh?
No, I think something that Suzanne stressed is interesting, how sometimes there can be some tension between policy and technical engineering, for instance. And I do think that policy should listen more to technical constraints. Policy tends to live in a world by itself where it wants to set some rules based on previous experience. And we all know that this great enterprise, this great experience that the internet has become is something that doesn't have a parallel in history. So it would be wise from the policy view to take into considerations, for instance, ideas such as DNS that draws from the idea of decentralization as a matter of resilience and protection. So maybe on the policy side, I would encourage policymakers to think about that.
Thank you, Eduardo. This is exactly the focus and objective of this school, is to bring different professionals together, from lawyers, engineers, all together, because concepts are the things that we all have to have in mind. I'm an engineer, not a lawyer, but I need to understand legal issues and policy issues, as the policymakers need to understand the technological concepts. Yesenia, ¿quieres comentarnos algo para cerrar el panel?
Would you like to mention something to close this panel? I wanted to pick these last few words, and as a lawyer, I think that there are many legal issues to take into account, and it is important for us to understand the technical things and to also to be able to develop some standards that can be applied. Thank you, Olga. Thank you, Yesenia from El Salvador, Eduardo from London, Gerardo in Buenos Aires, and Suzanne from Washington in the US.
Regards from Argentina to all of you. Un gran saludo desde Argentina. Espero que sigan bien. And I hope to meet you in person someday and somewhere in the future. Espero encontrarlos personalmente algún día en el futuro. Muchas gracias por haber estado acá con nosotros.
Thank you for being here with us, and to all the fellows, we are going to get together again in half an hour with a new panel. Thank you.